All right, so now we're going to go ahead and dive into 25-2. It's a special case for the for law of sine. It's called the ambiguous case, and you get this when you get a side-side angle triangle, which would look something like this. You know this side, you know this side, and you know an angle that's not included, that's not in between the two sides. Because if you did, you'd have a side angle side, and at that point you would use law of cosine. With the side-side angle, we have a table here that's on page 337, and it breaks things down. First thing you have to look at is you're going to look to see if angle A is an obtuse angle or if it's an acute angle. Obtuse, just as a reminder, is greater than 90 degrees but less than 180 degrees. And acute is greater than 0 but less than 90 degrees. The obtuse is pretty easy. So if you get an obtuse angle, you only have to look at these two top parts. And you don't have to calculate any height, you just compare A and B. When you have an acute angle, which is going to happen more often, you have 4 scenarios. 3 of the 4, you're going to have to calculate your height. The first one I always check is this one right here. Is A greater than or equal to B for one triangle? Because I don't have to do any math. If A is greater than or equal to B, I stop right there and I'm done. So let's look at some of these problems, a problem that we would ask. We're going to basically say construct a valid argument. Determine how many triangles are possible with the given information. Draw a sketch and show how many calculations are used. So let's do letter A here. Letter A says we have a triangle. And I always draw a triangle. Even if I get information that yields no triangle, I draw a triangle just for easy reference. So I want to label it angle A, angle B, angle C. So this becomes 30 degrees. And the side directly across from that, they give us little a equals 5. So 5's right there. So this is going to give us the law of sine proportion that we would use to solve all our problems. The other bit of information that they give us is B, which is 10. So this is a side-side angle, so this is an ambiguous case. First thing we look for, we look at angle A. Is angle A acute or obtuse? Well, 30 degrees is between 0 and 90 degrees, therefore it's acute. So we are going to use these 4 scenarios right here. First one I want to check. If angle A is acute and side A is greater than or equal to B, you get one triangle. So just fill those in. So my side A is 5. And it has to be greater than or equal to 10. Well, you've been doing this for a long time, and I don't know any time that 5 is going to be greater than 10. So this scenario doesn't work. So it doesn't have one triangle. So that's going to break this down to, next thing we have to do, we have 3 left. We have one where it says A is less than H, A equals H, or H is less than A, and A is less than B. So we're going to have to calculate our height. Well, what's nice on page 337 is they give you a formula for height. The formula for height is H equals side B times sine of angle A. So we're going to use this side right here and this angle. So we're going to plug those in. So my H equals 10 sine 30 degrees. Now from here, you could use the calculator for sine of 30 degrees, but I'd be really disappointed because you have a unit circle. And sine is the y value on the unit circle. The y value at 30 degrees is 1/2. Therefore, my H equals 10 times 1/2, which is actually 5. Now that I know my H, I go in and figure out which one of these are. So I look at my first situation. Right here. My side A is 5. Is 5 less than 5? No. So this one doesn't work. Does 5 equal 5? Yes. Therefore, this is going to be the solution. So this information will only give us one triangle. It's a little tedious to actually go through. What we do generally in the real world, when I solve these problems with a side-side angle, I actually don't go in and look at this bit of information. It's more of a feel. What I do is I set up, like we're going to solve for two triangles, which we'll do here in a second. And if it works, it's great. Then I know I have two triangles, if I can solve for two triangles. If I can't even solve for one, then I don't have no triangles. And if I can only solve for one triangle, then that works. And a lot of times you're going to see that with the angles. Your angles have to equal 180 in a triangle. If they don't equal 180, you don't have a triangle. Pretty straightforward.